Okay, this is intermission 2. So just to go over some more basics in computer science, I just wanted to cover some other topics. So first we will talk about IP addresses. If you're familiar with all this stuff, you can just skip this video and move on to Python 18. Otherwise, I'll just do kind of a 3,000 foot overview of all of these. So every single computer must have a unique address. That is called an IP address, which I'm sure you've heard of before. They are in the form of like a 12-digit number that's 3 numbers, period, 3 numbers, period, 3 numbers, period, 3 numbers. And those numbers can be anywhere from 0 to 255. So sometimes you have short ones like 1.2.3.4, and then obviously you can have ones that have all 12 digits. If you connect to the internet through an internet service provider or an ISP, you're usually assigned a temporary IP address for the duration of your session. If you connect through like a LAN, your computer might have a permanent IP address. So if you look and connect all of your devices over your router or your Wi-Fi or whatever, and you look at them, they'll all have IP addresses. And it might also obtain a temporary one from a dynamic host configuration protocol server, which is a DHCP, if you've heard of that. But in any case, if you're connected to the internet, you have a unique IP address. So next we'll talk about that once you're connected to the internet, how do you talk to the other computers? So that's protocol stacks and packets. So let's say your IP address is that 1.2.3.4 and you want to send a message to another computer with their own IP and you just want to say hello. It must be transmitted over whatever kind of wire connects your computer to the internet, whether it's cable or dial-up if you have that, or satellite, whatever. So you've dialed into your ISP from home and it must be transmitted over the phone line or your cable. It must be translated from alphabetic text into electronic signals, transmitted over the internet, translated back into alphabetic text. So how's that done? It's done through the use of the protocol stack. So every computer needs one to communicate on the internet, and it's usually built into the computer's operating system. You've probably heard of the TCP Ip Protocol Stack, which is very common. So that stack looks like this. It has a protocol layer. It starts with the application protocols layer, which is specific to applications like www, email, FTP. Then you have your transmission control protocol layer, which is TCP direct packets to a specific application on a computer using a port number. So you've probably played video games or used an application where it wants you to open a port number, or you've seen something served on a port number before. And then you have your internet protocol layer, which is the IP directs packets to a specific computer, and that's what uses the IP address to find that specific device. You have your hardware layer, which converts binary packet data to network signals and back. So that's like your Ethernet network card, your modem for phone lines, etc. So I've used my incredible artistic ability here to animate this or illustrate this, I guess. So you have your stack here, your application, your TCP, your IP, and your hardware. Then it sends it over the internet, and then the other computer gets it in the reverse order. It hits their hardware first, then their IP, TCP, and application. So when you send this message, if it's long, it'll be broken up into packets. I'm sure you've heard that before. And then they go through all of these layers. They're all assigned a port number. Many programs will be using the TCP IP stack and sending messages. After going through the TCP layer, they proceed to the IP layer. This is where each packet receives its address that it's headed to. So the other PC here, that's where it gets that address. Now that they have a port number that they're trying to get to and an IP address, they're ready to be sent. So the hardware layer takes care of turning all of the packets from that alphabetic text of our message into electronic signals and transmitting them over our internet line. On the other end of the phone is your ISP, which has a direct connection to the internet. So the ISP's router examines the address that you've put in there in each packet and determines where to send it. So it's kind of like a mail sorter. Often the packet's next stop is another router. So like the internet's just a huge web of routers. Eventually they reach the computer at the other PC end here, and it's just the reverse order. It works their way upward through the stack. All routing data that the sending computer stack added, such as the IP addresses and port numbers, is stripped from the packets. So when it reaches the top of the stack at the applications, the packets have been reassembled into their original form. So that might be like an emoji or a text, whatever. So that's the basics there, and that's good enough for now. If you are interested in learning about this stuff, there's a really good website. It's basic, but it's very, very well explained, and it's on web.stanford.edu. And you can just Google that, and you can type in "how does the internet work" and read up on it.